This video is about temperature conversions, and by the end of the video, you should be able to convert between Celsius and Kelvin temperature scales. So temperature is a measure of the average kinetic energy. If something is cold, the particles are only vibrating in a solid state, but they're always moving. And the warmer they are, the more they move. So in the picture on the left, you see that they're kind of stagnant, but they should be at least vibrating. And on warm, they're moving a lot more. You can also see it on the picture on the right even better. Cold, they move in a special small area. Hot, they move around a little bit more. Very hot, they can actually change position. So we have multiple temperature scales. The first scale actually came out as Fahrenheit. He was using mercury thermometers, and he marked where the mercury froze and where the mercury boiled, and then put marks in between. We don't base our chemistry on mercury, especially since it's a carcinogen, can cause cancer. So Celsius came out still using the mercury scale, but making it in terms of water boiling and water freezing. So he marked at 0 degrees where the water froze, and 100 degrees where water evaporated, and then put 100 marks between them to make it a metric scale, because anytime you're talking metric scales, they're on scales of tens and hundreds and thousands. Later on, Kelvin came out with an additional scale, which is basically the Celsius scale, but he adds 273 to each mark because he didn't want any of the marks to be negative. So on the Celsius scale, you can see where 0 is, and there's negative marks underneath. Would represent things that are like negative 20 degrees or negative 40 degrees Celsius. Kelvin decided that he wanted his lowest temperature ever to be 0 because that would make mathematical operations easier. And in order to make the lowest mark 0, he found the lowest mark on Celsius scale, which was negative 273, and added 273 so it would be 0. You'll see that the marks are exactly the same for Kelvin and Celsius. They're just 273 degrees up. And then since then, we have stopped using Fahrenheit everywhere except for in America, where we still report weather in Fahrenheit. But everything else, whether you're doing a calculation here in America or representing weather in anywhere else, you'll be using Celsius and then maybe converting Kelvin. So we're not going to use the Fahrenheit scale ever again. So the Celsius scale, remember, and maybe write this down and memorize it, that the freezing point of water on a Celsius scale is 0 degrees and the boiling point is 100. So below 0 would be negative. And again, the Kelvin scale is 273 degrees higher than that. So on the Kelvin scale, the water freezes at 273 and boils at 373. And the theoretical point of absolute 0 is where all molecular motion stops. We aren't actually there, but that means that there will be no negative numbers. Because I wouldn't even know what that would mean for molecular motion stops and negates. Like, that's not a thing, right? And the divisions, or the degrees, are the same as the Celsius scale, whereas Fahrenheit's way off. So the formula in your reference table T shows that Kelvin is the Celsius scale plus 273. Notice that Kelvin doesn't get a degree symbol. It's just convention that Celsius does. And if you wanted to figure out what the Celsius degree symbol for 150 Kelvin would be, you just put 150 in the Kelvin spot, and then solve for the Celsius spot by subtracting 273 from both sides. And then the Celsius came out to be, see, negative 123 degrees Celsius. Here's another example. What is the temperature in Kelvin of an object of 55 degrees Celsius? So this time I'm going to put 55 in for the Celsius scale and add 273 to get the Kelvin answer. So Kelvin is never going to be negative. It shouldn't even really be 0, and it should always be higher than the Celsius. At this point, you should be able to convert between Celsius and Kelvin at any point.